everyone, welcome back to my channel. Today we will talk about probability, simple probability, compound probability, expected value and permutation and combination through a one festive Kirana shop story, through a Mira Diwali Mela playbook, and by the end of this video you'll know how to calculate all of it in the Excel, and you will never look at the dice game the same way again. Our roadmap is we have 7 ideas, each tied to something happening at a Mira's Mila stall. And these are the old 7 ideas: simple probability, compound probability, expected value, permutations with and without duplication, combination with or without duplication. Each one builds on the last, so stick with me. Even if a term sounds unfamiliar, we will ground every formula in something you can picture. So first one is the simple probability. Let's start at a Mira lucky dice wheel. Every customer rolls a single six-sided die, and rolling a 3 wins us a discount voucher. How likely is that? The rule is simple. Probability equals favorable outcomes divided by total outcomes. And the Mira has one winning face, the 3 out of 6 possible faces. So 1 divided by 6 gives 16.67%. That's roughly a 1 in 6 chance, which Mira can also describe as the odds of 5 to 1 against. And flip it around, probability that customer doesn't roll a 3 is 1 minus 16.67%, which comes out 83.33%. That is 5 out of 6 chances succeed, with odds of 5 to 1 in Mira's favor. Meaning most of the customer walk away without a voucher, which is exactly what keeps her cost of running the promotion under control. So in Excel, this is one formula: divide the favorable outcome cell by total outcome cell, change either number, that probability recalculates instantly, right? So we will look into the Excel workbook. We will first look at this whole scenario, what we are talking about, right? So this is a simple probability, which is P is equal to favorable outcomes divided by total outcome. Our next one is the compound probability. Now Mira wants to run a bigger promotion, a double the markup price, and for anyone who rolls a winning face 3 twice in a row across 2 separate spins. This is where a compound probability comes in. When 2 trials are independent, meaning the second roll has no memory of first, and you find the compound probability by multiplying the individual probabilities together. So the chance of rolling a dice a 3, then rolling a 3 again, is 1/6 times 1/6, which equals 1 by 6, about 2.78%. We can also ask, what is the probability of rolling a 3 first, then rolling anything else? That's 1 by 6 times 5 by 6. That gives the 5 over 36, approx about 13.89%. So here's this trap everyone falls into. If Mira has already spun the wheel once and gotten a 3, so probability of her also winning round 2 is not 1 in 36 anymore. The first roll already happened and it's no longer uncertain. So only the second roll matters now. So probability is simply 1/6. So always ask yourself, how many trials are still actually in the future, right? So this is the trap. Once the round 1 has already happened, don't recalculate the compound probability. If Mira already rolled a 3 in round 1, the chance of winning round 2 is simply 1/6, not 1 by 36, because only the remaining trial is uncertain, right? So this is, we talked till now simple probability and compound probability. Next one is the expected value. Let's move from the game stall to the real business decision. Mira is considering stocking a new premium sweet box, Kaju Katli, for Diwali. She is not sure how it will sell, right? And so she scratches out 3 scenarios with estimated probabilities and profit or loss for each. Strong sales had 30%, likely profit of 15,000 rupees. Modern sales 45%, likely profit of 4,000 rupees. And weak sales, where she stuck discounted leftover stock, 25%, likely a loss of 9,000. To find the expected value, we multiply each scenario's probability by its outcome. Probability into the profit, then we have expected value of each scenario, and then we add it all together to find the expected value. 30% of the 15,000 is 45,000, 40% of the 4,000 is 18,000, 25% of negative of 9,000 is negative of 20 to 50. And then those add up to, we got the 45. So we got up to the 4,050 rupees. Because the expected value is positive, the stocking this new sweet line looks like a reasonable bet on average, assuming Mira's probability estimates are realistic. So if the total had come out negative, that would be a signal to reconsider or negotiate better terms with her supplier before committing, before setting a new stock line. So this is how we calculate the expected value. And next we have permutations with no duplication. Let's talk about Ravi, the Mira's nephew, who is organizing the Mela mini stage. And 8 shop assistants have volunteered to present the festival special, but there is only one room for 3 speaking slots. The order they go in matters, because the opening speaker sets the energy and closing speakers makes the final pitch. No assistant can present twice. So in this, order matters, no repeats allowed, and we have a formula of permut is equal to permutation with the number of assistants we have and opening speaking slot selection. So what the chance of having of this with the no repeats is this value. So this is a permutation problem because order matters, no duplication. So in Excel we have this formula where the number of people available with the number chosen, and then we get the values of 336 with the given values available. That's a lot of ways to arrange just 3 people out of 8. So if we change this further, if we have the number of people is 10 and the slots is 5, then it escalates fast, right? And the numbers jumps to 30,240. So that is the combinatorial explosion in action. That's what we talk about. Small increase in your inputs create a massive increase in your possibilities, right? Now let's talk about the permutation with duplication, where repeats are allowed. What if the Ravi decides assistant can present more than once? Say same person opens and closes segments. Order still matters, but now repeats is allowed. So this is the permutation duplication in Excel function. This is the formula is equal to permutation with A at the end, number of people available, and the number of people chosen. Right? So allowing the repeats always gives you an equal or larger count because you are not ruling out any option after it used once. So we have without duplication is this number, with duplication increased with this number because repeats are allowed, right? So because any assistant can fill any slot, even the same person twice. Now we'll talk about the combination without duplication. In this, we'll switch from stage to Mira's gifts baskets. She has 5 festival products: mithai, dry fruits, diya, candles, and chocolate. And each gift basket holds 3 different items. This time, order doesn't matter. A basket with mithai, dry fruits, and the same basket, no matter what order those items are placed inside. So in this combination, order doesn't matter and no repeats allowed. So we have the total number of products 5, with the items that can be fit inside is 3, and then we have a combination 10. So this is our formula in Excel is equal to COMBIN with the number of products available with the chosen number of products can be placed inside. So notice number is much smaller than permutation would give you for the same setup. That's because we are no longer continuing every possible ordering as a separate outcome, just every possible grouping. If we expand it to 8 available products, kept the basket at 4 items, this will grow to the 70 combination and still growing more slowly than the permutations midway. Because order no longer creates extra possibilities, combination grow more slower than permutations. Now we talk about the combination with duplication. Order here still not matter, but the repeats are allowed. Then we'll use this formula is equal to combine A at the end with the number of products available and chosen number of products, but a basket can repeat the same product 2 or 3 times, right? So finally, what if Mira lets her staff grab any 3 items freely for a basket, meaning a basket could indicate 2 or even 3 of the exact same product. Order still doesn't matter, but the repeats allowed. So this is the combination with the duplication, and we have this formula. And after calculating, we have 35 is the number. We will see this in Excel how it will calculate. So as with the permutation, allowing duplicates always increases or at a minimum keeps equal your total possibilities. So combination with duplicates still grow more slowly than permutation with duplication. Order is what really drives the explosion. So this is all we have. This is the sheet. Simple probability, favorable divided by outcome, compound is equal to, if we have a probability into the, if we have a, that's for example, just like we talk about, if we want the winning phase with the 2 rounds, so our chances is 1 by 6 into 1 by 6, right? That's the compound probability. What is the expected value? We have expected sum of the product, sum of the probability into the value, and their sum is the expected value, just to know if is it worth taking the risk introducing something new into the business. Permutation with the duplication order matters, repeats not allowed. This is the formula. Permutation with duplication order matters, repeats allowed. This is the formula. Combination where order doesn't matter, repeats not allowed. This is the formula. And a combination with duplication, order doesn't matter, and repeats allowed. We have this formula. Let's take a look in the Excel worksheet how we can calculate simple probability, compound probability, permutation and combination without duplicate. This is a simple probability. That's how we talk about the Mira's lucky dice week. Every customer at the Diwali Mela rolls a single 6-sided die and rolling a 3 wins a festival discount voucher. So we have a total possibilities is 6 and the favorable outcome winning phase is 3, which is rolling a 3. The possible outcome is 1. So probability of winning is C7 divided by C6, 1 by 6, which is 16.67%. Probability of not winning is 1 minus C10, which is this probability. Odds in favor of winning is 1 to 5, which is the 5 against 1 winning, odds against winning. And if we change C7 to 2, and then our values change, the probability change, probability of winning change, and their odds also change. Odd in favor of winning 2 to 4, odds against winning 4 to 2. Now let's talk about compound probability, where Mira runs the wheel twice for double the markup price, and each roll is independent and the die has no memory of first roll. So probability of having a 3 in single round is this percent, and when we have the compound outcomes rolling a 3 in round 1 and rolling a 3 in round 2, which is a C6 into C6, we have got this number probability around 2.78%. And what if in round 1 we got the roll of 3 and in round 2 there's not a winning phase, which is C6 multiply 1 minus C6, and then we get a probability of 13.89%. So when we talk about what is the trap, once a round 1 has already happened, don't recalculate the compound probability. What if the Mira already rolled a 3 in round 1 and the chance of also winning round 2 is simply P, around 2, 1 by 6, not 1 by 36, because only the remaining trial is uncertain. Now next we have expected value, where Mira introduced to decide just on a she want to make a decision whether she can introduce a new premium sweet box for Diwali. So she estimates 3 scenarios: strong sale, moderate sale and weak sale, and sets the probability of 30, 45 and 25% with the profit and loss. And then we get the expected value of when we calculate probability into profit, and then we have a expected value of 4500 and 1800 and negative 2250. The total expected value is 4050. So positive consider, okay, suggest stoking the new line is worth the risk on average, and if it's negative, she should reconsider the decision, or she can negotiate with the supplier. Permutation without duplication, when her nephew Ravi has available assistant 8 with the opening slot 3, and when we have permutation is equal to that's the formula, permut C7 into the C8, and then we have this number of order possible. And what if we change 10 and then opening slot 5, our outcome also change. So how fast the count grow is the combinatorial explosion. Permutation with duplication, so where repeats are allowed, right? So this is the number of the available assistants with the opening slots, because in room only three can speak. We have this value. Then we can put this formula, permutation A C7 into C8, because there is a duplication allowed, because that's why we have a increase in number. Without duplication we have this number. What if we change? So how this change, increase in the outcomes. What if, and this, that's also increase in the numbers. Combination without duplication, where order not matter and repeats not allowed, which have available products 5, but only items can be placed, 3 items can be placed. So we have combination of unique baskets 10, where no orders matter, repeats not allowed. And then we have combination with duplication. Then we have increase in number of value, because there is repeats are allowed. Same products can be one product same time 2 or 3 times in one basket. And we have 35 combinations compared to the without duplication. And this combination increase slower than permutations, because in permutation orders matter. In combination, order doesn't really matter. So now with this concept, with this dice wheel concept, how Mira used it to make a business decision to introduce new stock line to like Kaju Katli, Sweet Box, or any kind of the stock line. So you can make same business decision based on same very concept, and forecasting demand, pricing risk analysis, and scheduling resources, scheduling decision in business. And you can use the same formula, permutation, combination, without duplication, probability to calculate simple probability and compound probability, expected value to make a decision on if it's worth taking risk or not. And hope you understand this concept, and I will see you in the next video.